questions in the test will be the thing I told you to read on your own. Remember heterogeneous catalyst? You had to read those certain pages, like 3 pages. It's the one section on your own you're going to do. There are 4 stages. You got to know those 4 stages. If you don't know them right now, and that's okay. My guess is, number 1, you probably didn't read it. Number 2, even if you did read it, it was before Christmas, you forgot it. So you read it again. You find out those 4 stages, you take your own notes on it. One of the questions will be on that. The other question will be on a graph like this, where you got to explain things or talk about a catalyst and stuff like that with that graph. Okay, so those are the 2 short answer questions. All right, let's get to the beginning here. All right, let's do these from scratch. First page on the test is going to look just like this. I'm going to give you a rate law expression and an equation. I'm going to ask you for the orders of A, B, and C. I think everybody should be able to get this right. Oh, do be careful. I don't care if I've got a 2 in front of that, a 3 in front of that, or whatever. It makes no difference. Those coefficients up here mean nothing. These guys here, it's the exponents, the powers to which they raise, which is the order of the reaction, which hopefully you all know. So the order of A is 1. The order of B, it's not there, is 0. And the order of C is 2. Does everybody agree with that? Everybody have that down. Good. The order of the reaction, you sum up them, you sum those up, you get 3. Now, I've got to do changes based on knowing what the orders are. What would happen if I doubled A, tripled B, and quadrupled C? Just plug them in. Here's A. A being doubled raised to the first power. Here's C. Or B. B is tripled. I don't care. B's not in there. C, he's quadrupled raised to the second power. Now, 2 raised to the second power is 8, right? 4 raised to the second power is 8, right? No, it is not. And I'm sure a lot of people wrote 8. What is 4 squared, people? 16. And I get that all the time. It's a dumb mistake. I can't give partial credit on these guys. There's no partial credit for not knowing that 4 squared is 16. You got to be able to do that right. All right, so 16 times 2, did you all get 32 for that one? Okay. The next one, same thing. I'm just going to plug in my stuff here. I have 1/4 of A. I quadruple B. I don't care because he's 0 order, has no effect. And I tripled C. Tripled C. 3 squared is not 6. 3 squared is 9. 9 times 1/4 is not 9 1/4. It's 9/4. 9/4 is fine. 2 1/4 is fine. 9 1/4 is not fine. You understand why, right? Math. Okay. Now, the last one I purposely threw in here, 1/4 of A, doubling C squared means I've got 4 times 1/4. I do not get 0 from that. You put 0 down, you're getting no points, no partial credit. You get 1x or no effect. Either or. You cannot write 0. 0 means the reaction stopped. Got it? All right, good. Now, let's do the next one down here. These guys. I'm going to go to this board here because it's a little bit easier for me to write stuff. Actually, it's probably not easier for me to write stuff. I'll leave it on this one. So, in this kind of a problem, it's the kind where I did in lab, where we varied the concentrations over the course of 3 trials, and we kept somebody constant, we changed somebody else. Who would you have to choose? Who should you choose in this first example? There actually is more than one choice, I believe, but who's the first? Who's the best one? 1 and 3 is a great choice because I see that A is being held constant, C is being held constant, only B is changing. And the nice part about 1 and 3 is there's no change in the rate. So that's going to make this a real easy problem. Without writing anything down, I know the answer. I know B is 0 order because changing his concentration and leaving everybody else alone did nothing to the rate. Okay? But I have to show that somehow. I want you to show me. I want to be able to give you partial credit. So what do you show me for partial credit? You tell me which 2 trials you're taking. Trials 1 and 3. That's, you have to tell me. This is the same exact stuff that's in your notes. Matter of fact, it's the exact same problem, I believe, that's in your notes. I write down the rate law expression. Rate equals K, A to the X, B to the Y, C to the Z. Again, copying this is a waste of time since the exact same notes are in your notes. These exact same words. And I'm not going to write every word down as well as I did that. You need to listen to it instead of copying it. Okay? What happened to the rate between trials 1 and 3? Nothing. 1. What happened to K? Nothing if the temperature is the same. What happened to A? Nothing. 0.2, 0.2. Raised to the X power. What happened to B? He went up by what factor in this case? 1.5. You can't say 1/2, because if you multiply by a half, 1/2 times 0.2 is 0.1. It's 1.5, 1.5, and that makes him 1.5 raised to the y power. And this guy didn't change at all, also raised to the z power. So I've got all 1s except for this guy. I got 1.5 to the y power equals 1. What must y be? Y has to be 0. If he were 1, 1.5 would equal 1 to the first power equals 1.5. He has to be 0. You see why. Anything to the 0 power is a 1. Okay, now the thing is, I'm not going to have time on the review to do this, but how many times will I have to do this? 3 more times. 3 more. I'll have to do it. What 2 trials should I take next? What's that? 2 and 3? Because in 2 and 3, B is held constant, C is held constant, only A changes without doing the math, without doing all the stuff up here. This guy decreases by 1/2. Let's just do the final step of this. 1/2 raised to the x power equals, all these other guys stay the same. What happened to that guy? He went down by what? 1/4. Got it? What does x have to be? 2. So I now know that A is second order. I know B is 0 order. Let's just take a look. Since I know B is 0 order, let's take the look between trials 1 and 4. A stays the same. I don't care that B changes because he's 0 order. So neither of them has any effect on the reaction rate. This guy triples. He goes from 0.2 to 0.6. This guy triples. He goes from 2.4 to 7.2. So I love this. My favorite. 3 raised to the y, or whatever it is, z power equals 3. Therefore, z equals 3. Z does not equal 3. What does z equal? 1. Just because it tripled doesn't mean it's third order. If it was third order, it would be 3 times 3 times 3. It would have changed by 27. Okay, it did not change by a factor of 27. All right. Now, the last thing you have to do, somebody asked me in your class, do we still have to, am I done now? No, you have to solve for k. And the way you solve for k is you rewrite the rate law expression, rate equals k. We now know A is to the second power. We now know B is to the 0 power, and C is to the first power. We just figured that out by all of our previous work, and you must show that work in order to get partial credit in case you make a dumb mistake like we all do. Now I simply take any trial. Let's take trial 1. And I simply plug those numbers in with their concentrations and their units. And the rate is, what, 2.4 times 10 to the negative 6 molar per minute equals K, that's my unknown, 0.20 molar squared times well, what does it really matter? But no, not really, because it's going to be to the 0 power, and 0.20 molar to the first power. Now, when I do all of this, thank you. So quickly, I just dropped it off. All right, so I do all this. This guy drops out. This equals 1. Squared times molar is going to give me cubed. So I'm going to basically get 0.2 squared is 0.04 times 0.008. 0.008 molar cubed K equals 2.4 times 10 to the negative 6 molar per minute. I don't care what the actual number is. What will the units have to be? If this guy's molar cubed, the units would have to be, that 1 molar would get rid of it. I'd have to have molar to the negative second, minutes to the negative first. See why? Okay? And then whatever the number is, it is. You do the calculator of this guy divided by that guy, and it's going to be 3 times 10 to the something. I forget what. Okay? All right. Those are a big portion of the test. Let's look at the next thing. I already did that part. Here. These graphs. I hope you all realize with these graphs what they're showing you. And you can identify which reactant is which, based mainly on, it's over in this one, it's a little bit bigger, based mainly on the stoichiometry of it. Okay? The fact that this guy ends at 4, if this goes to completion, tells me that must be product C. You know what else tells me it's product C? The fact that it started at 0 and ended at some amount in the future. The guy that starts at 2 must be a reactant. The guy that starts at 3 or 1 must be a reactant. And he ends at 0, he must have been a reactant. So A, the red line, must have been, A must have been the red line. The yellow line must be B. And blue must be a C. Got it? You all have that down, I would hope. And the way you would get the rate is to get the what? The slope. Now, if it's a product, I could just get the slope. If it's a reactant, what will I have to do with the slope? The negative of it, because look at the slope of this guy. At any point, all right, that slope is always negative. It's just a matter of how it's changing. This guy's a positive slope. That guy's a negative slope. Y is decreasing versus Y is increasing. All right, now look at the questions on this guy. There will be a short answer question where you'll have to draw a graph like this, probably label things on it, and talk about a catalyst with it, okay? Let me go back there. Really, why won't it do this? There we go. Thank you. Let's answer the questions first. Endo or exothermic? My goodness, you should know this by Chem 1 standards, right? This is exothermic. Started off at high energy, ends at low energy. You should recognize that shape as being exothermic. If it starts at high and ends at low, it must have given off energy. Therefore, energy is released. Y'all have that, I hope. X. A lot of people get this wrong. X is not the activation energy. The activation energy is A. C is the what? What's C? Delta H. That's the enthalpy of the reaction, the change in energy from start to finish. X is actually the transition state. That's what it's called, the transition state, or the activated complex. You may see either word, activated complex or transition state. The highest point that it goes through. That was my definition of the transition state when I gave you the notes on that. Okay? Finally, we're going to use this graph to explain how a catalyst works. If I ask you to do that, I'm going to ask you, like I did in that one worksheet, to draw it. So you would draw another graph where the hump is not as big. Okay? Now, what if I asked you to do it where you had an intermediate formed? What would that hump look like? Right? And how many intermediates are formed here? Just one. Activation energy for that intermediate, activation energy for the final product, both of which better be below that. So if I ask you to define and explain a catalyst in terms of this graph, that's what you should have to tell me. Don't just say a catalyst lowers the activation energy. It does, but it also have to say, I know this sounds silly, but you have to say that it speeds up the rate of the reaction. Well, everybody knows that. And you have to say that it's not used up in the process. And you'd have to draw on here, especially if I ask you about intermediates, a graph that would have the correct number of valleys in it to show an intermediate. Okay. Speaking of which, we're going to get to those intermediates in a minute because we're almost there. Talking about these guys, talking about these mechanisms. Okay. I give you this, and I ask you, is this consistent or not? Let's take a look. First guy, NO and Cl2 are both used to make this intermediate. That intermediate is then used, again with another NO, to make the final product in the slow step. So a previous fast step takes an intermediate and uses it in the slow step. That's the same thing as if this guy had been used. So let's look what we have. All of those have been used now. NO twice and Cl2 once. Does that make sense? Absolutely. This guy is consistent. You might have just looked at it and said, well, no, he's not consistent because in the slow step you only have NO being used once. You'd be wrong. NO is used up here and Cl2 is used up there. So it's the same thing as using them when you use that intermediate in a following slow step. Is this guy correct? This is the easiest one. Is this guy consistent? Yeah. He's using 2 NOs and 1 Cl2. I want 2 NOs and I want 1 Cl2. That's exactly what I want. And I say, well, it's only one step. How do you know what's the slow step? If there's only one step, that is the slow step. And finally, this guy here. What would this rate law look like? It is not consistent. What would it look like if this were the actual mechanism by which this guy went? What would be different about this up here? The exponent would not be a 2 for this guy. It would be a 1, wouldn't it? Right? So this guy is not consistent. Got it? All right. Now let me just draw, because for the people who are at home and watching this, let me draw that guy over here, because that's the last one I wanted to talk about. So A plus X yields B. I hope you all got a chance to do this one. B plus C yields D. This guy's a slow step. This guy was a fast step. This guy's a fast step. And then D plus E yields F plus A. Now I just made this up, so obviously they're not real chemicals. I'm just trying to show you how do you identify the catalyst. Let's make the catalyst blue. Okay. Where are my catalysts here? Well, a catalyst is going to be somebody who's there in the beginning and then he's reformed at the end. Remember, he's not used up in the process. So my catalyst is A, isn't he? Okay? He's the catalyst. Let's talk about the intermediates. Let's do the intermediates. Let's do those in black. The intermediates. Well, an intermediate is something that's formed and then used up. Formed and then used up. Do we have more than one intermediate in this case? Yeah. We've got B, that's an intermediate, and we have D, that's an intermediate. Right? So both B and D. Let's do the overall equation now. Basically, you do not include catalysts or intermediates in your final overall reaction. So if I want the overall reaction, it's just going to be X plus C plus E yields F. Got it? Make sense? And lastly, I asked you, what would the rate law expression look like? The rate law expression would equal K, X to the first power, C to the first power, E to the first power, wouldn't it? See why? That would be the rate law expression. Because I used X one time. I'm sorry, whoa. What would E be to the? My fault, almost did it. What would E be to? Is E used in the slow step? No. So it basically be rate equals K, X to the first, C to the first. If you kept E in there at all, you better have him as to the 0 power. Okay? But he doesn't need to be there at all because he's assumed to be at 0 power if he's not there. Why is X used? Because X was used in a prior fast step, and then that intermediate is used in the slow step. Why is C there to the first power? Because he is used directly in the slow step. Got it? Okay, good. So to finish up, basically, tomorrow's test, the main thing I can't do for you, all right, is study the heterogeneous catalysts. Got to study that, which will include the 4 stages. Listen up. Anybody know what those 4 stages are? Right now, and that problem's going to be worth, no way it's worth less than 5 points. It may be worth 6, 7, or 8 points. You don't, probably 8 is a logical amount because you'd have to talk about the 4 stages, 2 points apiece. You don't know what those 4 stages are. You just started off with a 92. Okay? And the other things you should make sure you know are the same things I showed you on here a minute ago. These things down here. Know what the collision theory is and be able to explain things in terms of that, because there's going to be a lot of multiple choice questions with transition state and collision theory. And also the 4 factors. And don't mix up the 4 factors. If I want 4 factors, I want 4 factors. If I want 4 of the nature of the reactants, can you give me your 3 ways the nature of the reactants affects it? What are those? What can you have? Nope, temperature is not a nature of the reactant. Solution in water would be one. What else? What? I can't hear you.
Isotope?
Not isotope, wrong word. Allotropes. Allotropes.
Increase in surface area?
And surface area. Good. Okay, so those are your nature of the reactants. If I want 4 different things, I want temperature, nature of the reactants, concentration, and catalyst, right? Okay, and you need to talk about, know about each of those things, just like you need to know about the collision theory and the transition state theory, and how a catalyst works, a regular catalyst, and how a heterogeneous catalyst works. The difference between them.